You'd be surprised to find out the life-changing discoveries a person can make just by browsing Google Maps. Like this guy, who found a suspicious crater and might have made a major scientific discovery. In 2024, Canadian Joël Lupoint was planning a casual camping trip in his homeland. He opened Google Earth and zoomed in Quebec's Côte-Nord region. That's when he saw it, this unusual rounded structure. The measurement was impressive, 9.3 miles from one point to another, and there seemed to be a lake next to it. He was quick to print the screen and sent the image to a French geophysicist to see if he knew anything about it. Most times these images turn out to be nothing, or simply Google Earth watermarks. But he was surprised when he opened his email and saw the scientist's reply. The geophysicist said that, judging by the looks of the topography, Lapointe could have discovered a meteor impact area. Now, impact areas are really hard to identify. Since they've been around for millions of years, most of their shapes have been heavily changed by erosion. Scientists call these areas impact structures. They're usually circular or crater-like and are made up of deformed bedrock. It happens when a meteor falls into the surface of the Earth. Here's the thing. Since the crater has huge walls around it, these areas are usually mistaken for mountain ranges. That's what left the Canadian explorer confused. But the French geophysicist that analyzed the case gave him hope. That weird formation in Quebec had been classified as a type of volcanic formation. After Lapointe brought this subject back to the agenda, scientists had to dig a little deeper to find the truth. Until this recent discovery, scientists thought the area looked like that due to some volcanic formation. This is actually normal, since other things such as volcanism and sinkholes can be mistaken for impact craters. To verify, they asked for some samples of the site. This is a more reliable way to fact-check whether a meteor landed there or not. When the meteor hits the Earth, it brings different types of minerals from outer space. That's the wonderful thing about impact craters. They reveal a link between Earth and the outside universe. By now, scientists have cataloged most of the minerals that are native to our planet. When they're searching for an impact structure, they usually look for things such as teenite and chemisite, which can only be found in meteors. The biggest known impact crater in the world is the Vredefort crater, located in South Africa. This big thing was formed some 4 billion years ago. The asteroid that made it is estimated to have been one of the largest ever to strike planet Earth. When the researchers got the results of the site back in Canada, they did confirm that it contained zircon, a mineral that tends to show areas of impact. There's no way to guarantee that Lapointe really found an impact crater, but scientists are organizing a research mission over to the area just to make sure. If it turns out that it really is an impact crater, that's pretty huge news, since the last discovery was made in 2013. Another one of these mesmerizing discoveries came from a 15-year-old boy. William Goddery was also a Canadian, and for some reason loved looking for long-lost Mayan cities. Different from the previous story, William had an intention and a research methodology. He had studied many books on Mayan civilizations. He believed that Mayans built their cities in relation to the stars in the sky. So he opened a book and mapped all the cities that have already been unearthed. And that's when he noticed something important. There is an area in the Yucatan Peninsula in Mexico where archaeologists have unearthed 2 Mayan cities. But on the constellation map, there are 3 stars. He thought to himself, could this mean there is a lost city waiting to be discovered nearby? William Goddery is known to be a science genius and has even won an award for this constellation theory. When he noticed that a 3rd city was missing from the 23rd constellation he was examining, he began to search Google Earth for satellite pictures that could help him solve this mystery. Advances in satellite tech have shed new light on long-lost Mayan cities such as Tikal. Located in the heart of the Guatemalan jungle, Tikal is believed to have been the capital of the ancient Mayan Empire. He had hopes, so he reached out to a friend inside the Canadian Space Agency to verify what he had found. Since he had already won awards for his research, he had friends in high places, and that's when things got interesting. According to the images, there was a large square area on the border of Mexico and Belize that looked like the remains of a city. William took the images to a remote sensing expert. They studied the images thoroughly and concluded that the area could be housing 30 buildings and even a large pyramid. William named the new city discovered as Mouth of Fire. However, his theory was very much contested inside the archaeological community, and many Mayan experts worked to debunk William's findings. Experts say that constellation theories are too unscientific. Renowned anthropologists and astronomers said William's methodology was an act of creative imagination. Still, a 15-year-old teen almost found a long-lost Mayan city, which is pretty exciting if you ask me. What about these tiny dots that appeared on images of Google Earth? These strange spotted circles were found in the middle of the Algerian desert. A YouTuber browsing on Google Earth found these circles and discovered that people had been debating over their origin for years. He thought they were a glitch from satellite images. There are dozens of them, stretching for miles and miles in a straight line. They're far away from any town, road, or human activity, making it hard to understand if it was man-made or just a natural phenomenon. To settle this mystery, he interviewed the people who took Google Earth's pictures. He found out they were 100% true. The circles were there in real life. They appear in multiple pictures from multiple years. Now, at first, he guessed they were the result of oil activity. Algeria is a rich area for natural resources, so this made sense. To find out if the area is worth extracting, companies usually undertake seismic surveys. They're a way of analyzing the Earth's surface by sending shock waves into the ground. Depending on how these waves bounce back, you'll know what is located underground. There was another possibility. The Sahara is a very dry area of the planet. The average high temperatures in summer are over 104 degrees Fahrenheit. To survive there, people need to find ways of accessing water. So, his second guess was that the circles were kind of ruin or leftover from ancient water wells. But when he talked to an expert, he found out they weren't ancient water wells. You can see some of these traditional constructions in other cities on Google Earth, and they look really different from the mysterious circles. He decided to travel over to Algeria to find out the truth. He drove 99 miles into the heart of the desert, and when he gets there, he sees it. A huge crater dug on the sand, surrounded by 12 smaller holes. It kind of looked like the ancestor of a modern clock. There, he found something he couldn't spot on Google Earth: thin metal wires. When the curious YouTuber and his teams started to dig in the sand, they found old dynamite and some sardine cans. Apparently, they were hiding the truth. The Sahara Circles, as they were famously called, were not the historical leftovers of seismic surveying. Back at the time when these circles were made, this technology didn't even exist, but they were sure related to oil exploration. The dynamite holes were an ancient method of oil searching, and the sardine cans? Well, they were left by the workers who were exploring the region. Another Google Earth mystery solved. Wow, this port is so buzzing. Thousands of people come here every day to work, cargoes come and go, fishers are weighing their catches for the day, and even posh cruise ships pop in here to show this idyllic place to all the people on vacay. The ocean shore is fantastic. People walk along the beach eating ice cream or building sandcastles. Oh, and by the way, right now we're standing where the Sahara Desert used to be. Normally, our lifetime is too short to see any major changes. We don't notice mountains rise or the way rivers change their course. Entire valleys may be sinking, but it usually takes too long for them to sink entirely. Still, a group of scientists recently noticed there's a new ocean being formed really fast, and we can even witness it appear. Look here! It's the Afar Triangle. There's the Horn of Africa Peninsula not far away. It's the exact site where the sixth ocean is being born at the moment. Wherever you are, you're basically standing or sitting on a tectonic plate. You're just sitting on a couch watching this video? Cool! Your couch is standing on the floor, your floor makes part of your house is standing on the ground, and if you take a deeper look, it all stands on one of 15 principal tectonic plates. Together, these chunks are referred to as lithosphere. It's like a nice apple pie. The crust is the lithosphere, and the fragile apple filling is everything that's on the planet's surface. If the crust cracks, the filling leaks out. And this is what any earthquake is like. A tectonic plate, aka the crust, moves. The filling, also known as houses and people, is disturbed. Africa is made up of two plates, the Nubian and the Somali ones. Yeah, that's a large pie. And it seems like these two plates are constantly separating. It leads to an oceanic spreading ridge. It looks like the African continent is literally unzipping a part of it at this moment. A 345 square mile chunk of the Sahara Desert just split, so the magma rose. It triggered a series of earthquakes across Ethiopia, Eritrea, and Djibouti. And it's not just some minor earthquake. There are lots of fumes rising from those fissures, and it smells like sulfur. Phew! The eruptions slowly push the old lava sediments away, which is followed by creation of the new seafloor. The crack is filled with magma, and when it cools, it forms the new oceanic floor. If this process doesn't stop, the Red Sea will finally flood the area, forming the Sixth Ocean, and Africa will be split into two parts. So we'll basically have two Africas. But wait. Neither you nor your grandchildren are going to see that Sixth Ocean. You'll only have 5 of them throughout your life. Same with our future generations. Same old Pacific, Atlantic, Indian, Arctic, and the Southern Oceans. Before the oceanic floor gets solid and before the Red Sea actually starts flowing in there, many thousands, if not millions of years must pass. The continents move as fast as your nails grow. And imagine that the longest nail ever seen in history was the thumbnail of an Indian man reaching almost 6.5 feet before he cut his nails. It took him almost 60 years to grow it. Now think how far the continents will have to move by the time you celebrate your 100th birthday. Spoiler, it's not going to be very far. But anyway, you can witness some minor changes that take place even now. All those cracks that may not seem that significant so far make all the landscape in the Afar region look really unique. There's a couple more reasons for this uniqueness. Meet Erta Ale in Ethiopia, the volcano famous for its world's longest-lasting lava lake. It's located in the Afar Depression, also known as the Afar Triangle. By the way, depression refers to the sunken area. There's nothing sad about it. It's not the only volcano in this area. Eritrea, known as the Nabro volcano. It's never erupted, yet the lava in this area is pretty active. More volcanoes are to come because of the tectonic plate movements. They pull away from each other, and the Earth's crust gets thinner. The weaker the area is, the more volcanoes there are. Okay, the plates are separating, and it's kind of inevitable. It's just the question of time. This process is also called the Afar plume. We'll get more volcanoes, it's inevitable either. But how does it happen? Remember that apple pie? Yes, it was delicious. Well, things are actually much more complicated. The outer layer we walk on is relatively delicate and is made up of multiple broken pieces. It's like the eggshell or a lattice top on a pie. Let's take a deeper look at all the ingredients of this pie. If you cut a slice, you'll see it's made up of many parts, and there's something called the asthenosphere under the lithosphere. It's part of the Earth's mantle. Yeah, complicated. So the asthenosphere gets heated from within and it rises, just like the dough when you put it in the oven. Remember those cracks on the surface of a freshly baked loaf of bread? Man, I'm getting hungry. Anyway, this is basically what happens to the Afar Triangle, and those cracks make this area split, creating those famous rifts and valleys that will possibly become so large and will probably get flooded so that the world's sixth ocean will appear there soon. Or not. Nobody's sure about it. Okay, but since the tectonic plates and, which is logical, all the continents are always on the move, we'll probably have more continents in the future. The answer is yes and no. If a part of Africa does split, we'll get one more continent, which is going to be even smaller than Australia. But there's one more possible way of how things will go. Chances are, in the next 250 million years, in the distant 250 million years, there will be no more transatlantic flights. And a walking trip from Japan to Chile will be possible too. Way too long, but possible. It's all happening now, and the first results will be noticeable in some 50 million years from today. I won't be around then. Australia will move towards Southeast Asia, and it's going to fit in just perfectly. And Africa will be pushed to Southern Europe. Still, these transformations will take a really long time. People and continents have something in common. Remember that continents move as fast as our hair and nails grow, just about 1.2 inches a month. Some of them move even 5 times faster though, but even this speed is too slow for 4,500 miles distance between Africa and Europe. One theory tells us the things we've already seen before. Well, you didn't see that with your own eyes, neither did any of your ancestors who came to America across the Atlantic hundreds of years ago. The fact is, all the continents were once one landmass known as the Pangaea supercontinent. Even though it formed over 300 million years ago and split about 180 million years ago, give or take, it might come back together. So kangaroos can easily migrate from Australia to the UK if they feel like it, but the latter might be accidentally crashed while all the continents merge together. The Americas would collide, Antarctica would drift to them, and it all will merge with the already collided Africa-Eurasia. In this scenario, one large ocean and one large continent will appear, namely Novo Pangaea. Another possible scenario claims the continents might merge into the uniform landmass or form a circle with a large sea inside and the super Pacific Ocean outside. This continent is referred to as Pangaea Ultima. The third theory might be already coming to life. The Pacific and the Atlantic Oceans might just cease to exist, forming the new ocean basin. Eurasia will be split to form a new ocean, and all the continents will migrate to merge into the supercontinent Orica. And the fourth and last theory claims that the Pacific and the Atlantic Oceans will remain almost unchanged, and all the continents but Antarctica will merge into one, leaving poor Antarctica even more isolated and abandoned than it is now. Nah, don't feel bad. Since all the continents keep drifting northwards even now, it's quite probable that almost all of them will meet up somewhere at the North Pole.
The world's largest fence spans over 3,100 miles from Queensland to South Australia. If stretched out, it could easily connect London to New York. And if you'd walk next to it, you'd need 6 months to complete the journey. It wasn't built to safeguard the Australian border. Why would it, since Aussies are just surrounded by water? It wasn't meant to protect some important building either. Its purpose is to keep some animal species away from each other. It was back in the late 1800s when Australians started building parts of this fence. They wanted to create a barrier separating the lively, bustling part of the country where cities like Melbourne and Sydney thrive from the harsh, dry outback. They used wooden posts dug deep into the ground, linked up with wire mesh standing about 6 feet tall. Some parts of the fence even have a second electrically charged layer. To make sure this fence did its job, they added some red and white lights to help guard things even at night. A team of over 20 people work full-time to keep things in check here. And every year, local authorities chip in around $750,000 to keep the construction in shape. Why all this trouble? The main reason was dingoes. These gingery, wolf-like creatures are Australia's largest carnivore mammals, and they're also apex predators. They were causing a lot of trouble to local farmers, especially in southern Queensland, where they often go after sheep. For the most part, the fence has been doing its job okay, but it's not foolproof. Some dingoes still manage to sneak through. Other times, wild camels end up crashing into it. That's because Australia has quite a massive camel population roaming around. But this man-made solution did more than locals expected. They thought there would just be fewer dingoes within the fence, but fewer dingoes mean more kangaroos. And more kangaroos mean more competition with the sheep for food. It's not just the bigger species feeling the squeeze. The smaller animals and the greenery also went through changes. With all this competition in a smaller space, locals noticed less diversity in the plant life and small animals. The soil became less nutritious over time, affecting plant growth. Plus, the fence acts as a roadblock for animal migration and seed dispersal. Even the sand dunes are feeling the effects, with less grass cover to hold things together. When scientists looked at kangaroos on both sides of the fence, they noticed that the young pups inside were lighter and tinier on average. The outsiders had bigger feet and heads for their age, and it wasn't because they were eating a different diet. The kangaroos that were stuck sharing the land with dingoes had to bulk up faster to survive. On the flip side, those inside the fence took it slower because they weren't under the same type of pressure. These had to compete with a lot of other creatures for food, so a bigger size wasn't a priority anymore. Researchers are still not sure if this difference is a quick fix or a long-term gene adaptation. What about domesticating dingoes? Wouldn't that help? Many think dingoes were once pets in Australia, but it's not known for sure. These days, they're pretty wild, just like wolves, hyenas, or coyotes. Most of them don't need packs to survive and are solitary hunters with sharp instincts built in. So taming them isn't going to be easy. Still, taking down the construction is not an option for now. Australians are so strict when it comes to making sure dingoes are kept away that they even put laws in place for people who mess up with the fence. Leaving a crossing gate open can put people behind bars for up to 3 months. Damaging the fence can cost people 6 months' worth of their freedom. It wasn't the first time Australians thought a fence could help with animal issues. Before they needed it for dingoes, they experienced a serious bunny invasion. Cute as they are, rabbits were damaging the land used for farming, so locals thought of a 3-part fence. The first one stretched all the way from Ravensthorpe in the south to Pardue Station on the Pilbara coast. It was over 1,100 miles long, making it the longest unbroken fence globally at the time. All these bunny problems could have been traced back to a man named Thomas Austin. Back in 1859, when he first came to the land down under, he thought it would be a good idea to release a few rabbits into the wild, thinking it would add a bit of charm to the place. But since rabbits aren't native to Australia, they didn't have any natural predators at the time. They're also pretty adaptive creatures, needing just some grass for feeding. They reproduce at astonishing speeds too. A mama rabbit can have 4 litters a year, with as many as 5 bunnies each. Pretty soon, their numbers boomed. By the late 1880s, the bunnies had caused so much damage that local authorities came up with a proposal. They'd offer the equivalent of almost $2 million today to anyone who could come up with a solution to this long-eared problem. Nobody claimed the prize, but a commission did gather a bit over a decade later and came up with the fence idea. Maintaining those fences was complicated. They had inspectors keeping an eye, with each one responsible for a stretch about 500 miles long. There were also these boundary riders patrolling smaller sections, using bikes at first, then switching to camels or using camels to haul buggies. They even tried using cars at one point, but they couldn't handle the rough terrain and constantly had punctured tires. In terms of its effectiveness, well, by 1902, rabbits were already hanging out on the wrong side of the fence. That's why, 4 years later, they put up another one. It worked for a while, so much so that the local authorities didn't bother helping out farmers past that second fence with rabbit netting loans. Those caught between the two fences, however, still had a rough time dealing with rabbit trouble. Soon enough, rabbits spread even over fence number 2, and it was clear the solution didn't work. In some areas, even while the fences were being built, those sneaky bunnies found their way past them. To this day, the rabbit population still sometimes puts the Australian officials through rough times. The dingo fence may be the longest one, but it's not the weirdest. The aquarium fence in Turkey might take that prize. This 164-foot aquarium fence was built to make sure the expensive villa's ocean view would be visible from every one of its levels. These days, it gathers a lot of tourists from all over the world, eager to see the variety of fish it contains, and even the octopuses. Putting up a see-through structure wasn't hard. The real challenge was connecting the aquafence to the Aegean Sea through a buried pipeline stretching across 13,000 feet of land. This ensures water constantly flows, keeping the aquarium clean and the fish happy. To make sure no one damages the delicate fence or steals any of the fish or two, the owner also invested in security. He installed a network of 17 cameras equipped with facial recognition. Visitors are free to look and take pictures, but step too close and you're likely to trigger alarms. Another one of those weird fences is New Zealand's bra fence. If you ever find yourself through central Otago, you might stumble upon a fence adorned with bras of all kinds of shapes, sizes, and patterns. Its story takes us back to 1999, when people in the area found 4 bras mysteriously hanging on the fence near Cardrona Valley Road. Some were a bit surprised, but then others started adding their bras to the decor. Some more bras appeared and it became a must-see spot for tourists. Its popularity was so high that at times it caused traffic problems in the area.
Scientists claim that Icelandia was a region between Greenland and Scandinavia that was more than 230,000 square miles, but is now underwater. The Earth was once a large pizza pie, with all the continents connected to each other millions of years ago, otherwise known as Pangaea. The North Atlantic region we know today was dry land from about 335 million to 175 million years ago. For many years, scientists and geologists assumed that the North Atlantic Ocean was birthed as Pangaea began to split apart roughly 200 million years ago. With volcanoes in the region where Iceland is, the country came to be just 60 million years ago as it broke off and sailed away from all the other lands. And since the Earth was like a large pizza pie, it divided like one. Many of the lands split up into many large and small pieces, creating the continents we know today. But this new theory suggests that the result of Pangaea's splitting left out some land that stretched for around 200 miles. And just about 10 million years ago, that piece of land submerged in the waters on the eastern and western side, leaving the tip of the land, which is now Iceland. When plate tectonics move, they grind on each other, which gave shape to our current landscape, all thanks to the mantle. This new radical theory goes against everything written in history books and what scientists have been studying. They began shaking heads, drawing lots of skepticism and criticism. But by analyzing the ocean floor under Iceland and the Earth's crust, we can assume that this idea isn't far-fetched. The crust beneath Iceland happens to be a lot thicker than the typical ones. Oceanic crust is made up of unique melted rocks compared to the land crusts where we walk and live on, and is a lot more denser. The thinnest layer on Earth is the crust, where life takes place. It's essential for water, growing food, gathering natural resources and minerals, and breathing in oxygen. It sinks below to the bottom, but right above the Earth's mantle. It also refreshes itself, since it constantly gets recycled into the mantle and back up. This is why the rocks in the oceanic crust are around 25 miles thick, compared to just 5 miles anywhere else. This is also reasonable given that it's in a hotspot for volcanoes. Magnetic surveys of the ocean floor show layers of molten crust in stripe patterns. Also, given the fact that the Earth's magnetic field changed its polarity over millions of years, it played a role in shaping the foundation of our landscape. But there isn't any concrete evidence to prove this new theory just yet. One of the first steps is to start digging the ocean floor near Iceland. Zircon is a very sturdy mineral that can last for billions of years despite erosion in the Earth's crust. By taking samples and studying them, researchers can estimate the geological age of the continents. This will make sure the crust is oceanic, which is thicker, or continental, which is the regular crust we walk on. This isn't an overnight project and would come with a hefty cost. Another way is to do seismic surveys that can measure echoes conducted on research ships. Drilling holes miles deep in the crust can also help with the research. But this would cost more than studying the zircon minerals. Some fossilized plants unique to both Scandinavia and Greenland might prove that Icelandia was once on the surface and possibly scattered with trees. It wasn't a cold land as it is today, so it may have had forests. But scientists still haven't found fossil evidence of animals common in both lands to suggest anything. But maybe time will tell. The theory goes deeper, which suggests that there was a greater Icelandia. With Iceland, Ireland, Britain, Scandinavia, and Greenland all in one microcontinent, it could be a destination of winter enthusiasts and great for skiing. It could be possible to connect Canada to Greater Icelandia by train over the ocean, which would open up the economy even more. Iceland is around 40,000 square miles, which is already quite big. And if the Greater Icelandia was present today, then Europe would be a completely different continent. Many theories are circulating about other possible hidden microcontinents around the world. Scientists aren't certain of the possibility of Icelandia's existence, but if all the studies conducted were done correctly, then the theory could change everything we know about Iceland and the North Atlantic Ocean. And this could pave the way for other sunken microcontinents around the world. Another theory out there is that New Zealand was the tip of a lost subcontinent, even bigger than Icelandia, called Zealandia. Studies show that it's separated from the supercontinent Gondwana between 79 to 83 million years ago. Scientists claim that it's the thinnest and youngest continent discovered underwater. Craton is a core rock that acts as the main foundation for most continents. It's at least 1 billion years old, but the continental crust that makes up Zealandia is just half of that, which makes it quite young. That means some Craton is missing, even though it holds some leftovers of older rocks and parts of the mantle. They're estimated to be as old as 2.7 billion years old. Scientists did some studies on the zircon crystals from New Zealand and found out that they're as old as 1.3 billion years old. The rest of the continents are more than 3 billion years old. Scientists studied the composition of the rocks in the bottom of the ocean around New Zealand. They're made up of silica and granite, which are found in continental crusts. The ocean floors mainly have magnesium and iron-rich rocks. They're also thicker and higher than regular ocean crusts around it. They conducted some studies and collected magnetic and topographic data to see the link between the Tasman and Coral Seas in the Cato Trough region. This is the narrow strip between Zealandia and Australia. Satellite data tracked tiny faults in the Earth's gravity to map out the crust of the ocean floor surrounding the area. They saw the mass that makes up Zealandia quite visible and almost the size of Australia. Even though the signs are there, this doesn't prove anything. It's possible that there are a bunch of microcontinents which all split apart when Australia broke free of Gondwana. Back then, the supercontinent was made up of South America, Antarctica, Australia, Zealandia, Arabia, and the Indian subcontinent. New Zealand is already not the biggest country out there, but if the theories are correct, then Zealandia will be 6 times its original size. Mauritius is a young island that's only a few million years old. Just 1,200 miles off the coast of Africa, it's believed that the tiny island came to life around 9 million years ago. The underwater volcanoes in the region spewed out so much lava that it formed the land today. But scientists found zircon rocks that are more than 3 billion years old. It may also be part of a continent submerged underwater called Mauritia, which is just a quarter of the size of Madagascar. The zircons they found were embedded in solid rocks and not just in the sand, which may rule out that they just washed up on shore from another continent. Some scientists are still not convinced. They suggest that discovering rocks that stand out from the other typical ones brought by an eruption could skew the scientific community to this theory. But just like how Icelandia could be part of Greater Icelandia, Mauritia was once called Rodinia, which consisted of India and Madagascar. Theories suggest that Mauritia was covered in water when India broke away from Madagascar, something like 85 million years ago.
So, a mysterious discovery was made deep in the Red Sea, the so-called death pools. Woo, that's scary. In 2020, researchers embarked on a dive into the Red Sea. The mission spot was in the Gulf of Aqaba, between Saudi Arabia and Egypt. Near the end of their expedition, as they ventured deeper into the darkening waters, they noticed some strange seaweed floating above the seafloor. They decided to use a remotely operated vehicle and investigate it. Suddenly, they discovered these strange, motionless lakes of water within the sea. These are called brine pools. They're basically pockets of salty water deep on the ocean floor. And when I say salty, I mean it. Sometimes they're up to 8 times saltier than the ocean water itself. Mysteriously, they don't mix well with the surroundings. They formed millions of years ago, sometime during the Miocene epoch, back when weird creatures roamed the earth, like me, and deeply buried mineral deposits dissolved into the water. The largest pool spans about 170,000 square feet. Meanwhile, 3 smaller ones are under 107 square feet each. At first, this discovery didn't seem that scary. But here's why they're so horrifying. Not only are they disgustingly salty, they also lack oxygen. Now hold on a sec, isn't that normal for something that's underwater? Well, it turns out the Earth's waters are full of oxygen, and at least half of this element on our planet comes from the oceans. Just like plants on land, marine plants such as phytoplankton, seaweed, and algae munch on sunlight and produce oxygen through photosynthesis. They release lots of it into the surroundings. Marine life then eats half of it, so only about a quarter of the oxygen that we breathe actually comes from the oceans. Just like us, sea creatures need this element to survive. Without it, they can't breathe and support their metabolism to live. That's why these pools are super dangerous for most of them. It's like a puddle of thick syrup for bugs. When they get in, the poor things immediately suffocate and pass away. Which is why the pools are surrounded by a graveyard of marine animals. But let's see how these things can exist in the first place. Have you ever tried making ice cubes from salty water? Spoiler, it's pretty hard. When you add salt, the water gets harder than usual to freeze, a phenomenon that has a funny name, freezing point depression. Oh, that's because salt interferes with the hydrogen bonds between water molecules. As it finally freezes, stuff like particles, dirt, or dissolved salts get pushed out to the sides. As a result, the salt's kind of squeezed out of the ice crystals and gets trapped near the edges in small bubbles or pockets. Something similar happens in the ocean when seawater starts freezing under super cold polar caps. The salt doesn't freeze with the water. Instead, it gets pushed out, forming a super salty cold liquid, the brine. And then it sinks down to the ocean floor. On a large scale, all this process also helps currents to form. Despite being so dangerous, the pools are still full of microbial life, because microbes couldn't care less, they'll survive anywhere. There are literally thick mats of them in the brines. There are also some salt-loving creatures, like shrimps and eels, hovering around the pool's edges. They're being super creepy, waiting to catch unsuspecting prey that ventures too close to the toxic death pool. Ew. Well, it sounds icky, I know. But this discovery gives us some fascinating insights into how life might have originated on Earth. We already know from the evolution theory that we came from the ocean, but now scientists think that life might have begun in the deep sea in some super dark, oxygen-free places. These brine pools are like time capsules. They're one of the closest things we've found to the early Earth. They can tell us the planet's history of earthquakes, floods, tsunamis, and more. For example, they have some traces of rainfall that happened over 1,000 years ago. And they can also help us search for life on other water-rich planets. For example, Mars most likely used to have huge oceans on it. Now, NASA scientists want to send a special instrument called HABIT for a special red planet mission to study things similar to our brine pools. This will tell us more about how life appears and survives in the universe. There is lots of unexplored fascinating stuff like this in the Red Sea. That's why scientists conducted the so-called Decade Expedition and spent around 5 months exploring the place. This expedition was launched by the National Center for Wildlife. They made so many remarkable discoveries that now we've got 77 new research papers. For example, they found over 10 blue holes, incredible underwater sinkholes that host unique ecosystems. They also learned that dolphins can use those blue holes to protect their young from predators. Scientists also found traces of great white sharks, a creepy community of deep-sea lanternfish living in low oxygen conditions, and even a new coral species. It's the most resilient deep-sea corals that also vibe just fine without oxygen, like microbes we mentioned. Speaking of which, research also showed us some new ancient thermal vents and large blobs of microbial formations near Farasand Island. Now, can you believe that with all that, we only explored 5% of the ocean? It's divided into several layers based on depth. Each layer becomes darker and more isolated from sunlight as we go deeper. The places that no sunlight can reach are terrifying. Now, the fun, cute layer with dolphins and turtles is called the epipelagic or sunlight zone. It's so tiny, but even this layer is about 650 feet deep. Then we have the mesopelagic or twilight zone. It's the layer of mysterious octopus, shark, and other loners, which extend to about 3,000 feet down. And then the horrors begin after this one. We encounter the bathypelagic or midnight zone. It extends to 13,000 feet below the surface, about a half of Everest above you. Here we have the famous poor blobfish, squids, and anglerfish. Below it is the abyssal zone. It extends to about 20,000 feet deep. Since there's not much sunlight or oxygen, as we mentioned, most creatures here are quite small, like tube worms and shrimp. The darkness continues until we arrive at the scariest place of the planet, the place full of trenches formed by tectonic plate movements, the Hadal Zone. It's named after Hades, the deity of the underworld in Greek mythology. Just like Hades' realm is dark, remote, and guarded, the Hadal Zone is the deepest and most depressing part of the ocean. It starts at depths of around 20,000 feet and can go down to 36,000 feet and more. The famous Mariana Trench also belongs to this zone. Only 3 people in history have ever explored these depths in person, making it one of the least explored and most mysterious places on our planet. However, despite crazy high pressure, near freezing temperatures, and complete darkness, there are still things who manage to survive here. Guys like amphipods, which are critters who feed on dead material sinking from above, and the Hadal snailfish, which lives as deep as 27,000 feet. So scientists used to assume that if there's no sunlight, there wouldn't be that much oxygen around. But one day, a research team decided to measure the levels of oxygen in one of those deep zones. Surprisingly, the levels were super high. They checked the equipment thinking that it was malfunctioning, but nope, all the sensors showed the same thing. Turns out the oxygen was somehow generated by rocks. These small potato-sized rocks on the seafloor are called polymetallic nodules. They're rich in metals like copper, nickel, and cobalt, and they're basically like small batteries. When you put a battery in salt water, it can produce bubbles of gas, a process called electrolysis. In the same way, these rocks create tiny electric currents, which are powerful enough to produce the same gases, splitting water molecules into hydrogen and oxygen. It's the first time we saw oxygen being produced by some non-living minerals. This is what scientists now call dark oxygen. It turned out that about half of large marine species, or megafauna, were living just on dark oxygen alone. All these discoveries are reshaping our understanding of where and how life could evolve. It means that we might be able to find life on other planets or satellites with low oxygen conditions, like Enceladus and Europa, the moons of Jupiter and Saturn, and they have large bodies of frozen water on them. Wow! Welcome to Rapa Nui, better known as Easter Island. It's a tiny speck in the vast Pacific Ocean, 2,200 miles away from the coast of Chile. This island is most famous for its eerie moai statues. This place is also home to one of the most mysterious writing systems in the world, called Ronga Ronga. We found it on 27 small wooden tablets. For years, historians have been arguing about the true history of these tablets, and now we might have found the truth. Humans first set foot on this island in the 12th century. For many years, it was home to the Rapa Nui people. They were pretty isolated out there in the Pacific Ocean until Europeans arrived in the 1720s. Europeans brought with them lots of troubles, leaving only a small fraction of the native population alive. Later in the 19th century, a missionary, Eugene Iro, went to the island and discovered the wooden tablets with intricate symbols carved on them. He wrote how marvelous they are, but there are hundreds of them on the island, and that they can be found in every household. But unfortunately, not all of them survive to this day. We've only got 27 of them. Some of them were heavily weathered, burned, or otherwise damaged, and now they're scattered all over the world in museums and private collections. Some of the language's artifacts were carted off to Tahiti and then to Europe by Europeans, leaving none behind on Easter Island itself. The 4 sacred tablets found their home in a congregation in Rome. They were the ones used in the recent discovery. For years, historians have been arguing whether this writing system was made up by the islanders themselves or they borrowed it from Europeans. To find the truth, they decided to use a technique called radiocarbon dating. All organic materials, like wood, charcoal, and so on, contain a tiny amount of a radioactive form of carbon called carbon-14. When life comes to an end, things stop taking in carbon-14, and the amount they had starts to decay over time. By measuring how much carbon-14 is left in a sample, we can assume how old this sample is. This is how we learn the age of many fossils and artifacts. So, they looked at the age of some Ronga-Ronga tablets. 3 of them were crafted from trees grown in the 18th or 19th century, which aligns with the arrival of Europeans. However, one of them is older than the Europeans' first visit to the island. There are 2 reasons to believe that Rapa Nui people created this writing system themselves. First, Ronga-Ronga works differently from European languages. Decoding it is a pretty hard task. Unlike English, this language boasts over 400 unique glyphs, none of which resemble any known writing system. There were many attempts to decipher this language, and none of them were successful so far. And second, one of the tablets is shown to be from around the 15th century, before the Europeans arrived. The problem is that radiocarbon dating can only tell us when the wood the tablet was made from was cut down, not when the writing was put on it. And since we've only got one tablet to go by, this isn't enough to be completely sure. On the other hand, why and where would they preserve cut wood for over 200 years just to grab it and write something on it one day? But anthropologists and historians say that it's possible. Scarce wood resources might have led the islanders to reuse old driftwood, which could be centuries older than the writing itself. This is known as the old wood problem in archaeology. Plus, the tablet looks very preserved. It was maintained to protect it from wood-damaging insects, humidity, and so on. That's why it survived over the centuries. Whatever is written on it, it was probably important for the Rapa Nui people. Now, all of these are guesses and clues, but scientists are cautiously optimistic. They believe that Ronga-Ronga could be one of the rare instances of independent writing invention, like those of the Sumerians or the Egyptians. But we need more evidence. In the Rapa Nui language, rogo-rogo means to recite or to declaim. Not everyone could write, only a select few. Probably only the elite of Easter Island, mostly men, knew and could read this written language. After colonization, none of them survived. So now we have to rack our brains trying to figure out what's written here. First, scholars can't agree on what type of script it is. We aren't even sure that this was their language. But even if it was, we don't know whether it's a primitive form of writing or a fully developed system. In the 1990s, a linguist, Stephen Roger Fisher, believed he might have cracked the code of Ronga-Ronga structure. His idea was that these tablets conveyed cosmogonies. Cosmogonies are stories or narratives that explain how the universe was created and how natural phenomena came to be. They often come from ancient traditions and cultures, like those found in East Polynesia. The tablets could have talked about things like how the world began, where everything came from, and how different aspects of nature, like the stars or the mountains, were formed. This would also explain why only the wise elite could write. Fisher thought that Ronga-Ronga is a mix of logographic and semasiographic systems, which means that some symbols represent spoken words, while others represent ideas or concepts. But deciphering them would be very hard because it requires extensive memory and knowing context. because the symbols are more like hints than complete expressions. However, other language experts disagreed with his ideas, saying there were problems with how he put together his theory. Unfortunately, Fisher couldn't prove this hypothesis. Maybe these are just drawings. If we look at the tablets, there are some things that look recognizable: people, animals, plants, and geometric shapes. There are some birds. One of them looks like a frigate bird, which Rapa Nui people associate with the deity Maki Maki. There are also fish, centipedes, and so on, or at least these glyphs look like them. Could it be just art or a form of decoration? Maybe, but there are some problems. The glyphs show a high degree of complexity and structure. They also keep the same style. For example, there are several symbols that show something human-like with a raised hand. The only difference is different heads. As if it wasn't complicated enough, this unique writing style also uses a system known as reverse boustrophodon. This means that each alternate line is flipped upside down, resembling nothing seen elsewhere. We don't know why they would turn the tablet upside down after each line. But all this shows that they had some sort of system and organization behind these symbols. Plus, it seems like they use these tablets every day for some practical purpose. But there's some hope for the future. New technology, like AI and other computer programs, might help us understand lost languages. We already started creating algorithms that could help us solve other mysteries, like the Voynich manuscript. Academics even organized the Vesuvius Challenge, a machine learning competition that, in 2023, cracked the riddle of the ancient Herculaneum scrolls. The scrolls were buried under volcanic mud after the catastrophic eruption of Mount Vesuvius in 79 AD. In real life, the scrolls are very fragile, so deciphering them would be a very hard task. But with digital scanning and machine learning, it's much easier. They have a rich history. They most likely belong to the personal library of an Epicurean philosopher named Philodemus. These scrolls contain very important insights into Greek philosophy and Latin literature. If we decipher more of them, we'll learn more about the rich history of the Roman Empire. Hey, look at this rock. At first sight, it looks like a regular boring rock, the likes of which you can see when walking along the beach. Its color doesn't stand out, and its weight is pretty regular, around 4 pounds. But everything changes when you learn that this rock was born on Mars, traveled all the way to Earth, and ended up in Antarctica. Now the story sounds much more fascinating. So let's find out the details. Researcher Roberta Score, who worked on the ANSMET project, which stands for Antarctic Search for Meteorites of the Denver Antarctic Program, found this meteorite in 1984. If you want to decipher the name of the space traveler, I can help you. It comes from the place where the scientists spotted it, the Allen Hills of Antarctica, hence ALH. And then we've got the year of the discovery and the number of the sample. If you think that Roberta picked up the rock and exclaimed something like, "Woohoo, I'm holding a chunk of Mars," I'll have to disappoint you. At the very beginning, it was totally unclear where the meteorite came from. And one thing confused researchers even more. The meteor was very different from other meteorite groups found on our planet. Okay, but then how did they finally figure out it was a visitor from Mars? All thanks to traces of gas similar to those that make up the atmosphere of the red planet. We learned about its composition thanks to the brave Viking lander that carried out the necessary analysis in situ in 1976. Anyway, back to our rocky discovery. It's actually very special, and not only because the rock arrived from far, far away. Among those several thousand meteorites found on Earth, just around 100 have likely come from Mars. And even so, our guy is different from them and seems to be part of a separate group. So let's go into the past and follow the life story of this cosmic traveler. It most likely formed around 4 billion years ago on its home red planet. One day, which wasn't very different from others, turned out to be life-changing for this peaceful rock. A meteorite impact catapulted into space, and it started its own journey as a small asteroid. At that time, it was way larger than at the moment of discovery on Earth. At one point, ALH got close to Earth and, who knows, probably decided to explore something. That's how, 13,000 years ago, it ended its space journey by colliding with our planet. At the moment, this Martian fragment is the oldest we've got. But at first, it wasn't all that popular. Only in 1996 did it become way more famous after a groundbreaking discovery. You see, some NASA researchers started wondering, well, the fragment is obviously very old, but then, could it have recorded any traces of life that could have been thriving on Mars at the time ALH formed on the red planet? And guess what? Those scientists turned out to be right. They detected traces of very fine magnetite particles. Those were completely similar in structure and chemical composition to the particles we have on Earth. They're called magnetofossils, and magnetotactic bacteria produce them. So it might mean that, at one point, there were some forms of life on Mars. In April 2020, scientists from the Japanese Space Agency made another discovery. They detected nitrogen containing organic material of Martian origin in our meteorite. So, who knows what new astounding secrets further examination of the meteorite might reveal? At the moment, though, all you can do is travel to Antarctica and find more of them. The thing is, this place is great for meteorite hunting. Surprisingly, we have found nearly 50,000 meteorites in Antarctica, and hundreds of thousands are still waiting to be discovered. Each of these space rocks can tell us a story of the evolution of the solar system. For example, the very first lunar rock found on the icy deserted continent proved that chunks of space objects larger than asteroids can also end up on Earth. So, let's say you got inspired and decided to go meteorite hunting all the way to Antarctica. Well, get ready for some serious challenges. Despite their potential abundance, finding space rocks isn't as easy as it might seem. You'll have to visit remote areas, and there's still no guarantee that you'll be able to spot a meteorite. And that's actually a huge problem. Meteorites are vanishing from sight. Currently, scientists find about 1,000 meteorites in Antarctica each year. But according to a new study, about 5,000 more get hidden out of sight every year. The culprit is warming temperatures. Worried scientists created a model that could help them figure out where those meteorites might surface. This model was quite complicated, taking into consideration snow cover, surface temperature, the speed at which ice flows, and even the steepness of the terrain. After that, they ran simulations under various warming scenarios. It turned out that meteorites indeed sank out of sight as temperatures rose. To say that the researchers were upset is obvious. They didn't expect that climate change would affect their work so much. Even though those areas are below freezing, people still managed to ruin a crucial archive of the solar system. But let's get back to your meteorite hunt. If you want your chances to find one to be higher, travel to the base of mountains or outcrops where ice, which usually flows to the lower ground, is forced to move upward. But make sure to take your windbreaker with you. In those places, powerful winds brush away snow, exposing bright, vivid blue ice. Instead of melting, this ancient ice can change directly into water vapor, and it helps expose meteorites that would otherwise remain hidden. You need to hurry, though. Meteorites at the surface disappear quickly. Even when temperatures are well below freezing, the rocks can still absorb some of the sun's heat and melt the ice. It's like they're creating underground, or shall I say under ice, tunnels for themselves, sinking and hiding from sight. Sometime later, refreezing closes the entrance to those tunnels, effectively trapping meteorites inside, tucked out of sight. Now, scientists admit it's very tricky to find working methods to spot meteorites. And if we don't hurry and develop such methods, we might lose between 80,000 and 250,000 space rocks in total. No wonder scientists are on a mission to find more meteorites. They're focusing on meteorite stranding zones. Those are places where meteorites often gather on the surface because of specific features of geology, ice flow, and climate conditions. As you already know, you can find meteorites on blue ice without snow cover. This makes meteorites easy to spot. But finding such hotspots is often pure luck. Or you gotta sit day and night, scouring maps and satellite images in attempts to spot blue ice zones near research stations. Let me introduce Veronika Tolinov, a glaciologist, and her team. They've taken things to the next level by developing a smart Antarctic-wide map. To do it, they've used machine learning and satellite data from NASA, the Canadian Space Agency, and others. This map highlights areas where meteorites might be hiding based on past finds and all kinds of climate and ice data. Apparently, the best places to find meteorites are along the edges of the continent and near mountains with blue ice. Unfortunately, it's not just the blue ice that matters. The temperature and speed of the ice flow are also super important. For example, if the ice flows too quickly, meteorites get swept away before they can accumulate. So, if you want to find a meteorite, you have to wait for very precise conditions. The surface temperature has to stay below 16 degrees Fahrenheit almost all the time. Otherwise, meteorites sink. You can start with the Allen Hills region. Yup, that's where our ALH friend was discovered. This area is kind of a meteorite gold mine with more than 1,000 finds. But there are even more promising places, like the Fimbulheimen Mountains, and no one has searched there yet. You might be the first. In any case, with this new map, researchers developed a where-to-go index that ranks the best meteorite hunting spots, making future field trips much more targeted. And with plenty of blue ice regions still unexplored, there are tons of meteorites just waiting to be found. So, what are you waiting for?